All right, let's go.
Number 10. The standard answer. Nothing. And why that answer is not satisfying. Before we get into the theories, let's address the answer most people get when they ask this question. Nothing existed before the Big Bang because time itself began at the Big Bang. There is no before. Asking what existed before the Big Bang is like asking what is south of the South Pole. The question assumes something that does not exist, a time before time. This is Stephen Hawking's answer. It is Augustine of Hippo's answer from the 4th century. It is technically the answer most consistent with standard cosmology. And it is deeply unsatisfying. Here is why. The Big Bang was not an explosion in space. It was an expansion of space itself. Every point in the universe was compressed into an extraordinarily hot, dense state, a singularity, and that state began expanding. The singularity is where our current physics breaks down completely. The equations of general relativity produce infinities at the singularity. Infinities in physics equations means the model has failed, not that reality has failed, that our description of reality has run out of road. The honest answer is that we do not know what existed before the Big Bang because our best theory of gravity, general relativity, cannot describe what happens at singularity conditions. We need a theory of quantum gravity to describe the first moments and whatever preceded them. We do not have one yet. Everything else on this list is what physicists and cosmologists propose might be true once we have that theory. Number 9. The eternal inflation model, an infinite ocean of expanding space. Inflation is not just a theory about what happened after the Big Bang. It is a theory about what is still happening, right now, everywhere, eternally. The inflationary model, developed by Alan Guth in 1980, proposes that in the first fraction of a second after the Big Bang, the universe underwent an exponential expansion. Space expanded faster than light. A region smaller than a proton became the size of a grapefruit in something like 10 to the minus 32 seconds. But here is what Guth and others realized later. Inflation doesn't stop everywhere at the same time. Quantum fluctuations cause inflation to end in some regions while continuing in others. The regions where inflation ends become bubble universes, each with their own physical constants, their own laws, their own Big Bangs. The regions where inflation continues keep expanding exponentially, generating more and more bubble universes. This is eternal inflation, an infinite sea of inflating space with bubble universes nucleating continuously, like bubbles in an infinite ocean. Our entire observable universe, everything we have ever seen or will ever see, is one bubble, one among an infinite number. Each bubble is separated from every other by an inflating space expanding faster than light, making communication or contact between bubbles physically impossible. What existed before our Big Bang under this model is the inflating background. Our Big Bang was not the beginning of everything. It was the moment our particular bubble stopped inflating and its energy converted into the hot, dense plasma we call the Big Bang. Before our Big Bang, inflation. Before inflation, more inflation, eternally, in all directions, with no beginning. The disturbing implication is that eternal inflation may have no starting point. It may be truly eternal in both directions, which means the question of what came before is not answered but dissolved. There is no first moment. Number 8. The Cyclic Universe, the Big Bang that keeps happening. What if the Big Bang was not the beginning of the universe? What if it was the latest in an infinite series of Big Bangs, each one following a big crunch, the universe expanding, then contracting, then exploding again in an endless cycle? This is the cyclic model, and it has a long history. The modern version, developed by Paul Steinhardt and Neil Turok in the early 2000s, does not require a big crunch. Instead, it uses the framework of string theory's extra dimensions. It proposes that our universe exists on a three-dimensional membrane, a brain, floating in a higher dimensional space. A second brain exists nearby. When the two brains collide, the collision releases enormous energy, which we experience as the Big Bang. After the collision, the brains separate and the universe evolves. Eventually, the brains are pulled back together by a potential energy field. They collide again, another Big Bang. The cycle repeats indefinitely. into the past and into the future. What existed before our Big Bang under this model is the previous cycle, a universe that expanded for trillions of years, then collapsed back to the collision point, triggering another bang. Our Big Bang was not a beginning, it was a bounce. The model makes specific predictions. The gravitational waves produced by a brane collision have a different spectrum from those produced by inflationary models. Future gravitational wave observatories may be able to distinguish between them. If the cyclic model is correct, the universe has always existed. It has no origin. It simply cycles. Number 7. The quantum creation from nothing. The universe as a quantum fluctuation. In quantum mechanics, nothing is never truly nothing. The quantum vacuum, the lowest energy state of a quantum field, is not empty. It is seething with virtual particles constantly popping into existence and annihilating. Energy fluctuates around zero, never staying exactly at zero because the Heisenberg uncertainty principle forbids it. In 1973, physicist Edward Tryon proposed something radical. The universe itself might be a quantum fluctuation of the vacuum, a spontaneous creation event consistent with quantum mechanics, in which a universe-sized fluctuation occurred in a pre-existing quantum vacuum and persisted rather than immediately annihilating. The total energy of the universe might be exactly zero, positive energy in matter and radiation balanced precisely by the negative energy of gravity. If the universe has exactly zero total energy, it could have arisen from nothing, from a quantum vacuum, without violating conservation of energy. Alexander Vilenkin extended this idea in 1982, proposing that the universe tunneled quantum mechanically from a state of nothing, not a pre-existing vacuum, but literally nothing, including no space and no time, into existence, a universe from nothing through quantum tunneling. The mathematical machinery exists. The no-boundary proposal of Hawking and Hartle, developed in 1983, uses quantum gravity to describe the universe's wave function without a boundary condition at the beginning. Time itself emerges from the quantum state, rather than being pre-existing. What existed before the Big Bang under this model is a quantum probability, not space, not time, not matter. A mathematical possibility that spontaneously actualized. The deepest question, what is the quantum vacuum that gave rise to the universe, is still unanswered. A quantum vacuum requires quantum laws. Where did those laws come from? Number 6. The string theory landscape, a universe chosen from an almost infinite menu. String theory does not predict one universe. It predicts an enormous number of possible universes, each with different physical constants, different particles, different forces, different laws. The number of possible vacuum states in string theory, each corresponding to a different universe with different physics, is estimated at 10 to the power of 500, a number so large that makes the number of atoms in the observable universe look like a rounding error. This is the string theory landscape, and it creates a profound problem and a profound possibility simultaneously. The problem is that string theory cannot predict which vacuum we live in. With 10 to the power of 500 options and no selection principle, string theory appears to have no predictive power about our specific universe. The possibility is this. If eternal inflation is generating bubble universes and each bubble nucleates with a randomly chosen vacuum from the string landscape, then the reason our universe has the physical constants it has is not that they are uniquely correct, but that they are one of the inhabited options. We exist in a universe compatible with our existence because only compatible universes contain observers to notice them. This is the anthropic principle applied to the landscape. We do not need to explain why the constants are what they are. We only need to explain why we are in a universe where they permit our existence. What existed before our Big Bang under this model is the landscape itself, the mathematical structure of string theory from which our universe's specific physics was selected. Before our Big Bang was a different universe with different laws, and before that, another. The landscape is not a physical place. It is the space of possibilities from which physical universes are drawn. Number 5. the conformal cyclic cosmology. Roger Penrose's radical proposal. Roger Penrose, one of the greatest mathematical physicists of the 20th century, proposed conformal cyclic cosmology in 2010. It is one of the most unusual and specific proposals on this list. The universe ends in a big freeze. All matter decays. Black holes evaporate through Hawking radiation. What remains is a universe containing only photons and other massless particles, a cold, dark, empty sea of radiation. Here's the key. Massless particles do not experience time. Photons live outside of time. They are emitted and absorbed with no proper time passing between. In a universe containing only massless particles, there is no meaningful scale, no way to define size or distance, because nothing has mass to define a reference scale. A universe of only massless particles is conformally equivalent, mathematically identical in its geometric structure, to the beginning of a new Big Bang. The end state of one universe is simultaneously the Big Bang of the next. Time wraps around. Penrose calls each cycle an eon. We exist in one eon. The previous eon ended in a heat death that is simultaneously our Big Bang. What existed before our Big Bang was a previous universe going through its entire life cycle, billions of years of expansion, structure formation, and eventual heat death, concluding in a state that mathematically becomes our beginning. Penrose claims there is observational evidence, anomalous concentric circles in the cosmic microwave background radiation that represent gravitational wave imprints from massive black hole mergers in the previous eon. The claim is contested. Other cosmologists have argued the circles are statistical artifacts. The debate is ongoing. Number 4. The loop quantum cosmology bounce. The Big Bang that was actually a big bounce. General relativity predicts a singularity at the Big Bang, an infinitely dense, infinitely hot point where the equations break down. Most physicists treat this as a signal that general relativity is incomplete, that a quantum theory of gravity would replace this singularity with something finite and physical. Loop quantum cosmology is one of the most developed approaches to quantum gravity, and when you apply loop quantum cosmology to the Big Bang singularity, something remarkable happens. The singularity disappears. In loop quantum cosmology, space is not continuous. It is made of discrete quantized units, the smallest possible chunks of space. When the universe is compressed to extreme density, the quantum nature of space becomes important, and the quantum geometry generates a repulsive force, a quantum bounce that prevents the density from reaching infinity. Instead of a singularity, the universe reaches a maximum density of roughly 5 × 10 to the power of 96 kilograms per cubic meter, the Planck density, and bounces. The contraction reverses, expansion begins. What we call the Big Bang is actually a big bounce. A universe that existed before our time contracted, perhaps from a previous expanding phase, reached the Planck density and bounced into the expansion we see today. What existed before our Big Bang is a previous universe, contracting, governed by the same quantum laws as ours, full of structure, galaxies, stars, planets, all of which are compressed and mixed and scrambled in the bounce, so that our universe begins in the smooth, homogeneous state we observe in the cosmic microwave background. The bounce destroys the detailed history of what came before. We cannot observe it directly, but the quantum bounce itself and its implications for what the cosmic microwave background should look like make specific predictions that future observations may test. Before the next one, look at these. These are some comments from my previous videos. Thank you everyone for your love and support. All right, back to it. Number 3, the Ekpyrotic Model. Fire from a collision in higher dimensions. In 2001, physicists Paul Steinhardt, Neil Turok, Bert Govert, and Nathan Seiberg proposed the Ekpyrotic Model, from the Greek word ekpyrosis, meaning conflagration. Our universe exists on a 3-dimensional brane, a membrane in a higher dimensional space called the bulk. A second brane exists nearby in the bulk, separated from ours by a tiny gap, a gap so small it would be invisible to us, but physically real in the extra dimension. For most of cosmic time, the branes are slowly drifting apart. As they separate, a potential energy field between them causes our brain to expand slowly, accounting for the observed accelerating expansion we see today as dark energy. Eventually, the potential reverses. The brains begin drifting back toward each other. They accelerate, they collide. The collision is the Big Bang. The energy of the collision converts into the hot, dense plasma of the early universe. Matter, radiation, space, all produced in the moment of impact. What existed before our Big Bang under this model was a slowly contracting phase, our brain drifting toward the second brain in a universe that was already ancient. The pre-Big Bang universe was cold and nearly empty. The Big Bang was not a creation event, but a collision event. The Ekpyrotic Model makes specific predictions about the spectrum of primordial gravitational waves. Inflationary models predict a significant gravitational wave signal in the cosmic microwave background. The Ekpyrotic Model predicts an essentially undetectable one. Current observations have not detected primordial gravitational waves from inflation. That null result is consistent with the Ekpyrotic Model. Future gravitational wave detectors will test this further.
Number 2. The mathematical universe hypothesis. Reality is mathematics all the way down. Max Tegmark, a cosmologist at MIT, proposes something that sounds more like philosophy than physics, but is grounded in a specific and testable claim about the nature of reality. The mathematical universe hypothesis states that our physical universe is not described by mathematics, it is mathematics. It is a mathematical structure, and mathematical existence is the same thing as physical existence. Every mathematical structure that is self-consistent exists, not as an abstract concept, as a physical reality. The number of universes is not 10 to the power of 500, it is infinite. The infinity of all possible self-consistent mathematical structures. Our universe is one of them, the one we find ourselves in, with these specific laws, these specific constants, this specific history. What existed before the Big Bang under this model is not a physical state, it is a mathematical fact. The structure that is our universe, including its entire history, past, present, and future, exists as a timeless mathematical object. The Big Bang is not an event that happened at a particular moment. It is a feature of a mathematical structure that exists outside of time. There is no before, because the entire history of the universe, including the beginning, is a single timeless object, like asking what is north of the North Pole, but for the entire history of the universe. Tegmark's hypothesis is unfalsifiable in the traditional sense, because every observation is consistent with it, because every possible observation exists somewhere in the landscape of mathematical structures. This makes many physicists uncomfortable, but Tegmark argues that the alternative, that only some mathematical structures are physically real, requires an unexplained selection principle that is itself more mysterious than the hypothesis it replaces.
Number 1. We do not know, and that is the most honest answer. The question that defines the edge of human understanding. Here is the truth. Every theory on this list is speculative, not slightly speculative, profoundly speculative. None of them have been confirmed by observation. Most of them make predictions that current technology cannot test. Some of them may never be testable in principle. The Big Bang singularity is a wall. Everything before it is hidden behind the failure of our best equations. General relativity breaks down. Quantum mechanics in its current form cannot describe gravity at Planck scale conditions. The theory of quantum gravity that would let us see past the singularity does not exist yet. What we know about before the Big Bang is this: we know nothing. We have beautiful, mathematically consistent proposals. We have no confirmed facts. And here is why that matters. Every single confirmed fact about the universe was once a speculative theory. The Big Bang itself was called the Big Bang, mockingly, by Fred Hoyle, who thought it was absurd. Continental drift was dismissed for decades before it was confirmed. The expansion of the universe was considered a mathematical curiosity before Edwin Hubble confirmed it observationally in 1929.
The theories on this list are not fantasies. They are the current frontier of human thought about the deepest question we have ever asked. What came before everything? Some of them are wrong. Some of them may be approximately right. One of them, or something we have not yet conceived, is the true answer. The fact that we are asking the question at all, the fact that we have developed mathematics sophisticated enough to make proposals, the fact that we are building instruments capable of testing some of these proposals in the next decade, that is not ignorance. That is the beginning of knowing. We are the universe asking itself what it was before it began, and it does not know yet.
10 theories about what existed before the Big Bang. From nothing to everything, from a quantum fluctuation to an infinite sea of inflating space, from colliding brains in higher dimensions to a cyclic universe that has always existed, from a mathematical structure outside of time to the most honest answer of all, we do not know yet. The question is not going away, and neither are we. Subscribe to Cosmic Hives. See you in the next one.